In this video, we're going to continue where we left off in our discussion of factoring special polynomials. We discussed perfect square trinomials, and we discussed the difference of squares. There's also a pattern for the sum of two cubes and the difference of two cubes. So a cubed plus b cubed equals a plus b times a squared minus ab plus b squared. A cubed minus b cubed is a minus b times a squared plus ab plus b cubed. Let's check that these are in fact true. Well, I'll check the first one, and then you can check the second one. So if I multiply a plus b times a squared minus ab plus b squared, I'll distribute the... So I'm going to write out the steps. I'm using the distributive property. It's a times the first factor, the second factor I mean, plus b times the second factor. That's from the distributive property. Now I'm going to use the distributive property again to multiply a and the polynomial. I get a cubed minus a squared b plus ab squared. And then I'm going to distribute the b across. I get b times a squared, that's a squared times b, minus a times b squared plus b cubed. And as you can see, I have a minus a squared b, a negative a squared b plus an a squared b, those will cancel to make 0. And then I have an ab squared and a minus ab squared, those will cancel to give 0. And I am left with a cubed plus b cubed. And I'll let you check the other one, it's exactly the same. So let's apply it to factoring x cubed plus 27. Well, I can apply the difference, the sum of cubes formula. The sum of cubes formula where a is equal to x and b is equal to 3, and that gives me x plus 3 times x squared minus x times 3, that's 3x, and then plus 3 squared is 9. And I cannot factor x squared minus 3x plus 9 over to the integers anymore, because the integer factors of 9, I have 1, 3, 3, and 9, and I can't factor x squared minus 3x plus 9 using those. All right, the next example is 8y cubed plus 1. And again, I see two terms. I see an 8y cubed. I see that I can use a equals 2y, b equals 1. When I put that into the sum of cubes formula, I get 2y plus 1 times the quantity 2y squared minus 2y times 1 plus 1 squared. And I have to simplify that. That's going to be 2y plus 1 times 2y in parentheses squared is 4y squared, and then I have a minus 2y, and then a plus 1. Okay. And it turns out I can't factor the other quadratic either. All right, y cubed minus 64. This time I have a difference of cubes. A is w, b is negative, or b is positive 4. Then I can use the difference of cubes. So I'm going to get, okay, what's the formula? W minus 4 times w squared plus 4w plus 16. And then finally, for this last one, what's my a equal to? 3z, and what's my b? 2, if I want to use difference of cubes. Notice that if I made b equal to negative 2, I could actually get 27z cubed plus negative 8. And then I could use the sum of cubes formula. But we're going to use the difference of cubes formula. So we get 3z minus 2 times 3z in parentheses squared plus 3z times 2 plus 2 squared. That simplifies to 3z minus 2 times 9z squared plus 6z plus 4. All right, let's look at some examples where we use more than one factoring pattern. So remember that the first step in factoring any polynomial is to look for a common monomial factor of its terms. So for instance, to factor 2x squared plus 28x plus 98, before I go looking for sum of cubes or a perfect trinomial or a difference of squares, I want to try to factor a monomial out first. So I look at my constants, 2, 28, and 98. Do those have a common factor? Yes, I can factor out a 2. Now can I factor out any x's out of this and be left with a polynomial as a result? No, because the 98 is by itself. There's no 98x or anything like that. So first I'm going to factor, so 2x squared plus 28x plus 98, I will factor out a 2, and then I'll be left with x squared plus 14x plus 49. Okay, now once I've done that, then I can start looking to see if I can factor more. And I see that yes, I have a perfect square trinomial. It's a x plus 7 in parentheses squared. So that's fully factored. Let's look at another example, 75y to the 4th power minus 48y squared. So I want to look for common factors. Are there any common factors of 75 and 48? Yes, I can factor out a 3. Okay. And out of y to the 4th and y squared, I can factor out a y squared. So I get 3y squared that I can factor out. And then I am left with 25 times y squared minus 16. Now, am I done? No, I can actually keep going because 25y squared minus 16 is a difference of squares, because 25y squared is equal to 5y in parentheses squared. So now I use the difference of squares formula. I will get 5y plus 4 times 5y minus 4. And now I can't factor the 5y plus 4 or 5y minus 4 any further, so this is my final answer. The next problem says to factor 128r to the 4th minus 250r. Again, I'm looking for the greatest common factor of 128 and 250. That is going to be 2, it turns out. Because if I divide both sides, both of those numbers by 2, I get 64 and 125. Those have no common factors. So I can also factor out, can I factor out an r, or what's the biggest power of r I can factor? I can factor out an r because of the 250r and the r to the 4th in front of that's being multiplied by the 128. So when I factor out a 2r, I am left with what? 64r cubed minus 125. Now, am I done? No, because I can still use the difference of cubes. So I have 24 times, I have a 4r as my a, and my b is 5. So I get 4r minus 5 times 4r in parentheses squared times 4r times 5 plus 5 squared. That leaves me with 2r times 4r minus 5 times 16r squared plus 20r plus 25. And it turns out I cannot factor that quadratic any further. Okay, you can just use the strategies for factoring quadratics and see that it doesn't factor anymore over the integers. All right, one more example. X squared plus 6x plus 9 minus y squared. Well, I see an x squared plus 6x plus 9. I can factor that. Okay, I can't factor the whole thing directly, but I can group the x squared plus 6x plus 9 and factor that. And what I'll be left with when I do that is x plus 3 in parentheses squared, and then I still have a minus y squared. Now, can I factor this more? Yes, because I have a difference of squares. So this is going to be x plus 3 plus y times x plus 3 minus y. That's the complete factorization. Okay, so what we've done is we've gone over certain patterns to recognize when factoring. Perfect square trinomials, difference of squares, sum and difference of cubes. And again, first you want to factor out a monomial if possible, and then for the remaining factors, see if you can factor those more using the patterns that we've discussed. Okay, that's it for this video.